Hey guys, welcome to my channel. So in this video we're going to be looking at a binary tree traversal. We mainly have three traversals: in order, pre-order, and post-order. And of course we have lots of other traversals there, but mainly we do these three. And this is the video for the in-order traversal, right? So while doing that, we're also going to solve this LeetCode question, which is basically us doing in-order traversal of a binary tree. Before that, let's try to understand what that is, right? So, this is a rough binary tree. Excuse the drawing, but still. So what you do is you start from a node. So we start from 1, and then we go to the left. We keep on going to the left. So now the node is 2, and we go to the left of 2, which is 4, and we go to the left of 4, which is nothing. And then we come back to 4. Once we find out that there are no left nodes left, we come back to 4 and then we print this node. So we have 4 in here, right? And then what we do is we try to check the right node of 4, and it's not there, so we come back again. We go to 2, and we have traversed all of the left nodes of 2, so we print it. Then we go to the right of 2, which is 5 in here, and in 5 we again check for the left node, so we go here, and 6 checks that there's nothing. I should have used a different color, but nonetheless. So 6 doesn't have anything in here, doesn't have anything in here. Actually, it's not going to check that before, it's just going to come back to 6 first, and it's going to print 6, and then it's going to be like, let's check for the right a node of 6, and it doesn't exist. So let's go back. Let's go back to 5, and 5 says, my nodes are traversed. All of my left nodes are traversed. So things came back to me, and I'm gonna just print myself. So 5. Then we go back to 2, and 2 has already been printed. I don't know why 2 is looking like 1. It should be 2, by the way, guys. Okay, so 2 is already printed. Now we come back to 1, and all of the left nodes of 1 is printed. So we go 1, and then we go to the right part of 1, which is 3. It doesn't have anything. Again, it will not go to the right automatically, but you get the point. It's gonna go to the left, and it's gonna see that nothing is there, so it's gonna come back to itself. And it's going to print 3, and right is not there anymore. So this is our in-order traversal of this graph, which is kind of messy, but you get the point. Now, the crux of this is it follows a pattern like this. So we go left, we keep on checking the left recursively, and then once we come back, once we cannot find any node that is to the left of the node, we come back to the node itself, then we print the node, so ln, and then we go to the right part of the node. At least we attempt to do that, right? So it's basically left, the node, and the right part. So this is how we do it. Now let's try to implement this, now that we know what is in-order traversal. So there are 2 ways to do this. We're going to first try the recursive way, and then we're going to do the iterative way. Both are very easy, I guess. So we're gonna have to return an integer list. So I'm gonna just make a public list, because I don't want to pass on a list as an argument every single time. So we're just gonna call answer, and just gonna type this, and we're gonna have a separate function for our traversal, because we're gonna recursively call it. I don't want to mess with the actual function. Right. So let's call it. It's not gonna return anything, so let's call it in order, and it's gonna take in the tree node. Let's call it node. And now let's see. So what did we see? Right, we're gonna go to the left part of the array, and once we hit a null point, we're going to print the node, and then we're going to go to the right part of the array. Sorry, not the array. There's the array. I mean the nodes. You get the point, right? So let's do that recursively. So we're going to call the function for the left nodes of the node, And then once we hit a null point, we're gonna check the base case. So basically, once we hit the base case, we're gonna print, or we're gonna, in this case, we're gonna just add the value of the node to our array list. Answer to add node.val, and then we're gonna go to the right part, right? So we're gonna call the function itself recursively for the right part of the node. And our base case is, it's very simple. If we hit null, if node equals null, we just return back. And that's what we saw in our dry run of this of the binary tree that we saw in the whiteboard. Now let's just call the function and we should be done with that. So in order, I just pass on root and return answer. So let's run it. And it works. Let's submit it. And it works. So now let's do the iterative way, which is also very similar, but it's just we're using a loop, right? So I'm just gonna cut this from there to here, right? I'm not making a function anymore, so I'm just gonna use a loop inside of this main function. So I'm just bringing it in here. Anyway, so what we're gonna do is we're gonna implement a stack. So while doing recursion, we use the call stack, and now we're just gonna use our own stack. So stack of 3 nodes. Let's call it stack itself, and new stack. Right. So now what we're gonna do is, first of all, we're gonna have a separate node to traverse through the binary tree, because we're gonna be traversing. We're gonna go through the left and the right and whatnot. So we need that. Let's call it tree node. I don't know, current, I guess. We can call it anything, to be honest. It doesn't matter. Let's call it current, and we give it the name of the root. Now comes the main part. We're gonna have a while loop, and to be honest, we can just indefinitely just run it until we hit a condition, which is gonna be when our stack is just empty. It doesn't have anything. We don't need to do anything after our stack is empty, right? So we know we're done traversing. So that is gonna be our terminating case, and we're gonna implement that. No worries about that. But what was our first thing that we did? Right. So we go to the left nodes of the nodes that we check, right? So and we keep on doing that until we hit a null point. So while current is not equal to null, we're gonna keep on doing this. We're gonna add the node, which is the current node, to the stack. Stack.push current, and we're gonna keep on changing the current to, and we're gonna go to the left nodes of the current, right? So we're gonna basically traverse through the binary tree in the left way. So current equals to current.next. Sorry, not next, left. So basically, if you didn't understand it, I'm gonna explain it again. And by the way, if you didn't understand the recursive calls in the previous implementation that we did, I have a lot of videos on recursion that is really gonna be helping you. So check those out. And yeah. Now in this case, what we're doing is, until we hit a null point, as we did in the previous case, we're gonna just basically keep on adding the nodes into the stack, like the recursion did, and we're gonna keep on traversing the binary tree in the left direction. So now what we're gonna check is, so this is our terminating condition. If the stack is empty, then we're just gonna break. We're just gonna break out of this loop, so you don't have to worry that it's gonna run to infinity. It's not. We just have this. And now after checking this, what we're gonna do is, we're gonna, so we know that once we hit a null point, we came back to our node that was, that doesn't have any left element anymore. So we're gonna print that. In this case, we're just gonna add it to our answer, array list. So it's gonna be the fresh node, the most fresh node in the stack, right? So how to get that? We can just do like current equals to, we can just use this traversal material. We don't need anything else. Current equals to stack.pop. So it will give us the fresh node because that is the node that didn't have any left element. You get it? And if you're having any trouble understanding this, just run through this a few times in your head and you're going to get it. It's very simple. Now, what we're going to do is we're going to add this thing, answer.add current.val. And then what we did is we went to the right part of the array, right? So current equals to current.right. And that's it, to be honest. Then we just return answer, and that's it. So let me explain this again. So what's happening is we are changing our current to the latest or the freshest node there is in the stack, and we're doing that because that node doesn't have any left element. Because if there was, this loop would have entered another node again, right? So because we hit this, we came into these section of our code. So, and then what we're doing is, so once we get that node, the fresh node, we know that it doesn't have any left element, and we're just gonna add that to our answer array. And then what we did was we went to the right side of that, right? So that's why we now have our current node equals current.right, because we're going to the right side of that, and we're gonna do all the same things that we did for the starting root, and then it's just gonna traverse the whole array just like that. And if you're not getting it, just run through this a few times in your head, as I said already. It's gonna be clear like water. It's working. Let's submit it. And it works again. So yeah, guys, that was it. If you have any doubts, leave them in the comment section. And if you like my videos, do subscribe and like and all this good stuff. So see you again, and keep on learning. Thank you.